Alright, grade 11s, we're on to topic 4, which is the Cos Rule. So this rule is one of my favorites, and it's the last rule that we learn. So the Cos Rule can be viewed in 3 different ways, depending on how you want to write it out. So before we start, let's have a look. If this is angle C, then that would be called side C. If this is angle B, this would be called side B. And if this is angle A, that would be called side A. So the first way of writing the Cos Rule is the Cos Rule involves all 3 sides. So you could say C squared, which is opposite angle C. Now that will be equal to the 2 other sides squared added together. So B squared plus A squared minus 2 times A times B, so those same 2 sides, times cos angle C. Now notice that that means on the right hand side it's all about those 2 sides of A and B, so A and B minus 2AB, and then we say cos angle C, so that's between those 2 sides. Now that you don't have to start with C squared. You could say, well, B squared, now that will follow the same pattern. B squared would be equal to the other 2 sides squared, so A squared plus C squared minus 2AC, and now you would cos the angle between A and C, and the angle between A and C is angle B. Or you could say that A squared equals the other 2 sides squared, so B squared plus C squared minus 2BC, and now you would cos the angle between B and C, which is A. So notice that those are always matching because it's the angle, it's the side opposite that angle A, which is the subject of the formula. And everything on the right hand side is about the 2 sides and then the angle between those 2 sides. Now the reality is all of these things are the same. They don't give you 3 different ones on the formula sheet, they just give you one because they all mean the same thing. You just have to know how to set it up in your triangle based on what you want to do. Now before we start doing that, and it'll probably make a lot more sense when we look at some examples, we always have to know how to prove this. So what are we required to prove? They'll give you one statement. They won't ask you to prove all 3, they're all the same thing. They'll ask you to prove one of these. Now whatever one they ask you to prove, I always put the angle that I'm going to be working with at the bottom left. So if I'm going to be working with cos of angle C, I put that in the bottom left. So what are we trying to prove? Well, we were trying to prove here that C squared equals A squared plus B squared minus 2 times AB times cos C. So let's just remind ourselves that will be side C, this will be side B, this will be side A, and that's the angle, and it's between this B and A. So everything on the right hand side is all about A and B and the angle in between. Now as with all of our proofs so far, they've started with the construction. So I'm going to do exactly how I have done before, and I'm going to construct the perpendicular height from A down there. So I'm going to call that H. Now I'm going to call this point where it hits, I'm going to call that D, and this is perpendicular. Now I'm going to say, let us call the distance from C to D, let us call that baby D. So I'm going to say, let CD be equal to D. Okay, but the entire distance from C down to B is called A. So can I now write an expression for the distance from D to B? So D to B, if the whole distance is A, and now I'm taking away D, D to B would be A take away D. Now what I've done is I've created 2 right angle triangles. So the first one, let's call him purple triangle. I'm now going to go work in this triangle. You'll notice there's so many similarities between this and the proof of the other rules. So I'm going to say, let us work in that triangle. So in triangle, and this is ADB. Now we haven't done this so far in our proofs, but I'm going to use Pythagoras' theorem. And Pythagoras' theorem, if this is A minus D, if I fill that in, Pythagoras' theorem would have said that A minus D squared plus H squared is going to be equal to C squared. And that will be Pythagoras. We haven't used Pythagoras in ages. Now what I'm going to do now is manipulate that to write h squared as the subject of the formula. So fairly similar to the sine rule. So this would be, let me change that, h squared would be equal to c squared minus a minus d squared, just by manipulation. But that's not the only right angle triangle. The other right angle triangle is my green right angle triangle. So I'm going to do exactly the same thing. I'm going to say in triangle ACD, Pythagoras would tell me that d squared plus h squared would be my hypotenuse squared, which is b squared. And again, that's Pythagoras. And again, I'm going to manipulate this to write h as the subject of the formula. So h squared would be equal to b squared minus d squared. Okay, but, and this is similar to what we've done before, h equals h. They're the same thing. I'm talking about the same height here. So this expression for h has to be exactly the same thing as my second expression for h, because these two h's are the same thing. So c squared minus a minus d squared, which I got in my first triangle, must be the same as b squared minus d squared. Now that's kind of looking like where we're going. There's a whole bunch of squares and stuff. And now I'm just going to do a whole bunch of multiplying out and collecting up like terms. So if I look at the left, this is c squared. My bracket, if I square, which would be a squared minus 2ad plus d squared. And that's going to be b squared minus d squared. Now if I distribute my minus sign, this will be minus a squared plus 2ad minus d squared equals b squared minus d squared. So that was just multiplying out. Now what you'll notice is I have a minus d squared on this side and a minus d squared on that side. So those will disappear. I'm basically going to add d squared to both sides and they disappear. Now let's look at what we're trying to get towards. If I look at my required to prove, I'm trying to get c squared equals and then a whole bunch of stuff. So let me leave my c squared on this side and let me get rid of everything else. So I'm going to get rid of my minus a squared. I'm going to add it to both sides, and so I've kicked it over to the right hand side. So far I've got c squared equals a squared, which is what I wanted. Now what I want is plus b squared. Now notice there is already a plus b squared on that side. So I'm going to write plus b squared. So I've taken over my minus a squared, I've written in my b squared. My minus d squareds are cancelled, so the only thing I have left is this plus 2ad. So I'm going to minus 2ad on both sides, and that'll land up there. Now this is almost looking right, because I'm meant to have minus 2a if I look at my required to prove. But I'm also meant to have a b cos c. So where does that come from, and where does this d disappear to? So what we're going to do is we're now going to say, well, if we go and look at triangle ACD, which is the green triangle I had earlier. So let me draw it in blue again. So that's that triangle. Angle C is this angle at the bottom. So if I was going to look at what the cos of angle C is, cos by definition is adjacent, which is D, over hypotenuse, which is B. So can I now isolate D? So if I multiply by B on both sides, I get B cos C, and that gives me D by itself. Now that's perfect, because this D in my formula I want to disappear. So I'm going to replace it with B cos C, which if I go up is exactly what I was missing in that term. So I now just replace D. So therefore, if I continue from this point, C squared equals A squared plus B squared minus 2A. And now I'm going to replace D with B cos angle C. I've replaced D. And that's exactly what I wanted to prove. So there we go. Now they can ask you to prove any one of the formats. It doesn't matter. All I do is whatever format they ask me to prove, I look at my angle, which is C, and that's the angle that I put, the vertex that I put in the bottom left. Doesn't matter what else. You can put any of the other vertices in any places as long as that angle is at the bottom left. Now, just to write myself a note on this, when am I going to use the Cos Rule? What does the Cos Rule involve? Well, the Cos Rule involves all three sides. And the Cos Rule involves one angle. So there's actually two kind of cases where I would use the Cos Rule. And let's look at the examples to help us. So if we look at example 1, example 1 says determine the length of GH. Now my first port of call is this a right angle triangle? Because if it's a right angle triangle, I could go and use normal cos, normal sine, normal tan. Now this isn't a right angle triangle, so that's out the window. The moment that's out the window, I have two options available to me. Either I can use the sine rule, or I can use the cos rule. This question doesn't say anything about area, and so I'm assuming that that's not needed here. Now the sine rule, don't forget what we said, it's all about having a pair. You have to have an angle and its opposite partner to even think of using the sine rule. Do I have any pairs here? Well, I've got a side and I've got an angle, but I don't know both of them. I know the angle, but I don't know the side opposite it. And don't forget, for the sine rule, you need to know a pair. And so the moment that falls apart, then I look at the cos rule. Now let's have a look at why the cos rule will be useful here. I have been given two sides and the included angle. So the moment I've been given two sides and the included angle, that's perfect for the cos rule. Because the cos rule will say that GH squared, that's the third side. Now notice everything on the right hand side is about the two sides and the included angle. So that will equal to 12 squared plus 9 squared minus 2 times 12 times 9 times the cos of the angle between the 12 and the 9. So I've written myself that note there. That angle has to be between the two sides you're talking about on the right hand side. Now that right hand side is just a whole bunch of numbers. So I literally just plugged it all into the calculator, and I must keep my decimal places because I still have to do some working. So I get, and sometimes I just write dot dot dot, because in order to get GH, I'm just going to square root. And so I use my answer button and I square root answer my calculator, and then I can round up to two decimal places. So I get 17,78 centimeters. Now I always try and ask myself, does that make sense? And every now and again we draw a bad picture and it looks like an obtuse angle and it's not, or something. But we try very hard to draw accurately. So let's notice 115 is definitely the biggest angle in the triangle. I know that because the angles have to add to 180. So there's no ways you can have another angle that's bigger than 115. So opposite the biggest angle has to be the biggest side. So this side of GH has to be bigger than 12 and 9. And so 17.78 makes sense. So this was the first type of question where cos rule was useful. If you have two sides and an included angle, you can find the third side. Now the second place where the cos rule is useful is if you are given all three sides. That implies that I can go and find an angle. Now notice I would go through my checklist. Is there a right angle triangle? No. Can I use the sine rule? Definitely not, because the sine rule needs you to know a pair. So you need to know an angle and its opposite partner. I don't know any angles here, which means I have to use the cos rule. Now, depends on what angle they ask for. If they ask for Q, don't forget that the right-hand side, if I'm asking for Q, the right-hand side is all about the two sides and the angle in between. So this has to be 5 squared plus 11 squared minus 2 times 5 times 11 times cos angle in between. So always set up that side because you know that that's the two sides and the angle in between, and then you know where to put the sides. So my left hand side has to be my 12 squared. Now to be honest, this is actually where it goes wrong. Setting it up goes fine, and then doing the calculation goes wrong. And the reason being is that people pick up their calculator and they do all of that all together. And then what happens is you get an answer and it's undefined and you can't find Q. Now what goes wrong there? Notice how many terms you have on the right hand side. Those are two separate terms. So 5 squared is 25, 11 squared is 121. I don't have to show this working, but just for this first one. Now notice, this 2 times 5 times 11 is attached to cos Q. So you cannot include that with the 25 and 121 and simplify it all, because this is minus and it's 110, but it's not 110. It's 110 cos Q. So absolutely, all that I've done in that yellowy orange color, those are all just numbers and you can simplify them. They're individual number terms. But this 110 cos Q is one term and it's attached to a cos Q. So you cannot simplify the 110 with that. It's a separate term. So I would take my 144, I'd minus 25 and minus 121, and I get minus 2. But that minus 110 is glued to the cos q. So you'll know if something's gone wrong because you'll get an equation that doesn't work. Now when I divide by 110 on both sides, I get 1 over 55. And this is why I love the Cos rule. Any cos equations have two answers. However, the second answer is in quadrant 4. Now, an angle in quadrant 4 is above 270. Now, there's no ways that an angle above 270 can be in a triangle. And so the cos rule is wonderful because there's never two answers. You can just do shift cos and not even worry about a second solution, because the second solution for cos would never be able to fit into a triangle. It's only sine that has two answers below 180, which can fit into triangles. So I shift cos 1 over 55 and I get 88,96. Again, that looks plausible. It's opposite the biggest side, which is 12, and so it is a fairly big angle. But I do not have to find the second solution. I can just not even worry about it. Right, so far we've done the two examples where cos rule is useful. One, when you have two sides in the included angle, and you can find the third side. And number two, when you're given all three sides, you can find an angle. Now, because they asked for Q, I set it up in this way. If they'd asked for R, I just would have set it up in a different way. Right, let's look at example 3. Now, example 3 is a wonderful introduction to what we're doing next, which is mixing all the rules together. Now, often you'll get these questions where there are two triangles linked, and the key is going to be what are they linked by. Now, in this example, they're linked by the side PR. Now, I'm asked for the angle of x. Now, before we continue, in true form, I made a typo, and this is 243,5, so my apologies, so let me put that in. Now, if I'm looking for x, I go through my checklist. Is the triangle that x is in a right angle triangle? No. So sine, cos, and tan's definitions are not useful here. Can I do the sine rule or the cos rule in that triangle? Now, the sine rule involves you knowing a pair, so you have to know an angle and its opposite side. I don't know any of the angles, so sine rule is definitely out. Cos rule, if I'm trying to look for x, I would have to know all three sides for the cos rule, and I don't know the third side. I don't know PR. And so this is a classic example of where I know a lot of information in one of the triangles, which isn't the triangle I'm trying to work in. Now, that's not a problem, because I'm going to use my blue triangle to find out something that links me to x. Now, the only thing that links me to x is the side of PR. So can I use my blue triangle to find the length of PR and then use that to find x? So if we look at that, I've been given an angle. I don't know the side opposite it, but with 15, I do know the side opposite 15. And so immediately I'm thinking sine rule. Now, the only problem here is the angle that I want to know is Q, because I want to find PR. Don't go and find sides that do not link you to x. So if you find the length of PQ, that's great, you can, but it doesn't help you link to x. So try and avoid doing unnecessary calculations. So if I'm trying to find PR, I need to know angle Q. Fortunately, I know that the angles in a triangle add to 180. So I did 180 minus the two angles that were there, and sum of angles in a triangle, I get 139. Now that means I can set up the sine rule, because PR divided by sine 139 is going to be equal to, and I'm going to use 100 over sine 15, because that's the other pair that I knew. So once I've multiplied by sine 139 on both sides, I get PR is 253. Now I have to keep my decimals because this isn't a final answer. This is a stepping stone to working out x. Now keep that on your calculator, because I'm going to use the answer button when I have to do this. So this is 243,48, blah, blah. Now I can work in my green triangle, because you'll notice I've been given all three sides of the triangle, all three sides of the triangle. And so once you have all three sides, that's a classic Cos rule. Now don't forget that the right-hand side is all about the two sides and the angle in between. Right, so we're going to set up the right-hand side first. So my right hand side is going to be the 243,5 squared plus 102 squared minus 2, and this is going to go off my page at this rate, 243,5 times 102, and true as Bob. I've gone off my page, cos x. And on the other side, I'm going to have my 253,48 squared. Now the reality is the hard bit is now solving this. Now notice I wrote 0.48 here, but I've actually kept all the decimals on my calculator. Now I don't want to write down what all of these huge numbers are. So what I'm going to do is I'm going to work out my 253.48 squared, and I'm going to subtract my 243.5 squared and subtract my 102 squared, and then I'm going to stop. So I'm not actually going to write down that. I'm going to do it all in one step. So when I did that, I got minus, and it's 5,443,255, and that's going to equal, if I work out this coefficient, that's minus 49674 times cos of x. Now if I divide both sides by this minus 49674 to isolate cos x, I get that cos x is equal to 0.1, and again don't round off because it makes a huge difference in trig, all these decimals. So I keep my answer button on my calculator. Now that is going to equal cos x. And now finally I can shift cos that and get my answer. And so I got 83, and finally I can round off, 71 degrees. Now notice, does that look plausible? Well, that is a fairly big angle, and it does look a little bit less than 90. Now don't forget, sometimes we do draw pictures that aren't exactly wonderfully accurate. However, you should be able to tell from your picture whether you've got this right or not. So this one was difficult not because of the Cos rule, but because of the combinations of the triangles and using one triangle to get into another triangle, and then all these big numbers which weren't ideal. And that, everyone, is the end of the Cos rule.